Well, if video 1 was about adding, I bet you can guess what the second video is about. Let's go ahead and do some subtraction examples. Just like when you are adding radicals, before you subtract, you have to make sure you have like bases or the same radicand. So once you've got those like bases, you're going to subtract the coefficient. It's the same thing as addition, except now, we've got subtraction instead of addition. Now, I gave you some slightly more complicated examples just to make sure we kind of show you all the different types of problems you might see. So with this first one, you already have like terms because the radicand is the same on both. So I'm going to say 8 minus 5 is 3, and I've still got that radicand of 3. So 3 root 3 is my answer. Now over here, I've got 11 and 11, and then I've got this square root 176. So I'm going to need to simplify that a bit. Okay, so I pulled up a calculator because I don't know about you, but nothing comes to mind immediately about 176. I can tell that it's divisible by 2, so because it ends in an even number. So if I divide that by 2, then I get 88. So let's go ahead then and do 2 and 88. Now 88, let's see, let's do 4 and 22, I think is going to be the best way to go there. You could do 8 times 11 as well, but 4 and 22 is going to make my tree a little bit easier to deal with, I think. So then I've got a 2 and a 2, and 22 is 2 and 11. All right, so my pairs, as I go through, I've got a pair of 2's, and then I've got another pair of 2's, and then I've got that 11 left behind, which is nice. That means it's going to be a like term with the others. So let's go ahead and simplify that. Don't forget about your other ones. I've still got a 3 root 11 up here that needs to stay with me. So let's go ahead and do this. I've still got that 3 root 11 that I'm going to write right here. And then minus, I've got a 2 times a 2, and then I've got root 11 left behind. So I've got 2 sets of 2 that's coming out, and then minus another 11. All right, so that's 3 root 11 minus 4 root 11, because I've got to do multiplication before subtraction. That's just order of operations. And then 3 minus 4 is negative 1 root 11 minus another, remember there's a 1 there, minus another 1 root 11, so that's negative 2 root 11. And that is my final answer. All right, this one up here, we've got to do some simplification again. I'm going to split 80. I can do this one without a calculator. I'm going to do 8 and 10. And then 8 is 4 and 2, and 10 is 2 and 5, and 4 is 2 and 2. And then I'm going to bring all these other 2's and 5's down, otherwise I lose track. I'm going to go ahead and deal with this one first, and then I'll come over and do the other one separately. So let's see, I've got 1 pair of 2's and 2 pairs of 2's. And then I've got a 5 left behind. Now, notice there's already this 3x out front. So what I've got now is 3 times x times 2 from this set of 2's times another 2 from this set of 2's times the radical of 5, the square root of 5. So when I multiply these, 3 times x times 2 times 2, well, 3 times 2 is 6, times 2 is 12, and I've still got that x. So this first term simplified is 12x root 5. This other one, I've got to come over and simplify. So let's do that in a different color so we don't get confused. First thing I'm going to do is split my coefficient up from my variable. And then that x squared becomes x times x. 125 is 25 times 5. And then 25 is 5 times 5. All right, and then bring down my other 5. So then my pairs are, I've got a pair of 5's, I've got 1 5 left behind, and then I've got a pair of x's. So again, make sure that if you had a pre-existing coefficient, a number that was already out front, that you carry it down when you start to pull things out of the radical. So I've got this all-important -5 here that is going to come down and be -5. Then I've got this new 5 that's coming out. I've got the, oops, I left something out, sorry. I've got that x that's going to come out here. So I've got x, and then I've got that square root of 5 that got left behind. So now I can go ahead and do that subtraction, that multiplication. 5 times 5 is 25x root 5, but I've got this 12x root 5 that I need to subtract. So if you've got variables here, in order to be able to add or subtract, you have to not only have the same radical, but also the same variable and exponent, just like the rules we've always had. So in this case, that will work because I have an x here, I have an x here, I have a square root 5 here, I have a square root 5 here. So when I subtract this, 12 minus 25 is -13. I've still got an x, I've still got a square root of 5. So my answer then is -13x root 5. All right, you guys try a couple. Your examples are very similar to mine, so try them. Use your notes to guide you. Check your answers, and I will see you on the next video. Bye-bye.